Hello everyone, Jay Whitner here with Space Headlines. We do a quick recap of what's going on in space, and today we're going to be talking about the last week of February 2018. Our first item pertains to SpaceX. Their Falcon rockets have a fairing at the top, the nose cone, that is a fairly expensive item. It costs roughly $6 million. And in the past, these fairings have always been discarded. SpaceX wants to recycle the fairings. So it's sort of a two-part process. They want to use a parafoil to slow the descent of the fairings so they don't smack into the ocean at really high speeds and get damaged. And also it'd be ideal if they're not dunked in salt water, which is not the best thing. So in this first attempt to capture one of these fairings, their ship, the Mr. Steven, ended up a couple hundred yards away from where the thing landed. So close but no cigar in the first attempt. But a great idea to save $6 million for every recovery is huge for SpaceX. Also in SpaceX, they had some breakthrough in terms of their internet constellation that they're working on. If you're not familiar with this, they want to bring internet to everyone in the world. There's still a lot of people that can't get, high-speed internet, using a huge fleet of over 10,000 satellites to do this. The news item was that they launched the first two test satellites for this Starlink internet system, and they haven't really talked about the details very much for, I guess, competitive purposes. But apparently the test satellites were successfully deployed, and we'll hear more about them as time goes on. There was an interesting piece about commercial space business and ITAR and the interaction there. If you're not familiar with ITAR, it stands for International Traffic in Arms. The idea here is that many of the technologies that we use for a variety of purposes could have military applications. So we try to make sure that these technologies don't get into the wrong hands. And this is quite prevalent in the space industry, that there's a lot of these issues. So this is a balancing act between the needs of space businesses to market their goods and services, get customers and so forth, and to protect against these technologies getting into the wrong hands. The Space Council is aware of these issues. Vice President Pence has talked about this, and they do seem to have a will to streamline regulations and hopefully find a good balance between the needs of the space community and the real concerns that led to ITAR in the first place. In fantastic news, NASA is talking about people getting to the moon again. The timeline they're talking about is the late 2020s. So roughly 10 years from now, we should see people walking around on the moon. And we've had some changes in the nomenclature. If you're watching our show, you've probably heard of the Deep Space Gateway. There's been a renaming of the Deep Space Gateway. It's now called the Lunar Orbiting Platform. I'm still getting used to the new name, so we'll have to get acclimated to that. And the idea behind it is a little bit different. It's now going to be more of a way station to the moon. So payloads, people, and so forth, cargo, will leave from Earth. They will go to the Lunar Orbiting Platform. They'll then be moved into reusable landers that will take these people and cargo items down to the lunar surface and back. The timing of all this is pretty aggressive. The first piece of the Lunar Orbiting Platform is scheduled for launch in 2022, so that's 4 or 5 years from now. And as I mentioned earlier, people on the moon in the late 2020s, basically a decade from now. Also pertaining to the moon, we have some interesting information on lunar water. If you've been paying any attention to water and the moon in the last decade or so, Um, the thinking has been there is lunar water in very large amounts at the poles of the moon in craters that never get direct sunlight. So that's been the thinking. And it continues to be believed that that's still there, this water in the craters at the poles. The new information is that they're getting readings that indicate water and or hydroxyl is scattered all over the moon's surface. If you're not familiar with hydroxyl, it's similar to water, but it has one hydrogen and one oxygen. And some of the techniques they use to sense for these things, they're really sensing for hydrogen. So it's sort of, we see either water or hydroxyl here. This is very significant because the new information implies that hydroxyl is more common than water on the moon. It has great implications about lunar bases, lunar development, because it opens up broader areas of the moon for this activity. Recently, a lot of the concepts have talked about bases at or near the poles to take advantage of the water that's there. If hydroxyl is all around, we'd have a lot more latitude about where the bases might be located. We had some people leave the space station on a Soyuz vehicle, 3 people. They left the warm, cozy space station and landed in freezing Kazakhstan. So hopefully they're not getting frostbite over there. It was 2 astronauts and 1 cosmonaut who we're talking about. One interesting aspect of some of the stuff that they were doing is that it's been 32 years since we lost the Challenger and Krista McAuliffe. And her main objective from the mission was to do these neat science experiments aimed at exciting the children about science and space. And obviously she was unable to do those experiments. After all this time, the experiments have been done to excite kids about science and space once again. So I thought that was a really neat thing. Stratolaunch. At first glance, this image at the bottom might look like 2 airplanes, but really it's 1 giant airplane. The largest airplane in history. The idea behind Stratolaunch is that this huge aircraft would carry a rocket up into the air, and the launch point of the rocket, instead of being at a velocity of 0 on the ground, it's going at hundreds of miles an hour high up in the air where the atmospheric density is lower, so there's a lot of advantages to that. So the news item is increasing speeds of taxiing on the runway. They got up to 45 miles an hour. And the reason for this set of tests was they had concerns about some of the steering and braking systems on the aircraft. So they were testing those things. Apparently all those objectives were met, and Stratolaunch continues to move forward. IBM plans to send a space drone to the International Space Station. The name of this, I'm pronouncing it as Simon. It's spelled C-I-M-O-N. I'm not sure how they're pronouncing it. This is a joint venture from Airbus and IBM. What is unique about this drone inside the ISS when it gets up there, is it's going to have a very advanced artificial intelligence. And that has not been the case before about these a couple space drone type things that have been up at the International Space Station. We're seeing more and more of this activity. The Gateway Foundation just launched a Kickstarter for space drones to do a video about the need for them and to get that going. So this is a big trend coming forward. James Webb has had some issues that have been flagged by the GAO, the General Accounting Office, and it pertains to vibration associated with the sun shield. James Webb has to be really cold to operate properly, so they have sort of this giant umbrella over the James Webb to keep the sun's rays from hitting it. What the GAO is concluding is that we're looking at some delays from this problem. Delays increase costs. This may push the costs over $8 billion, which apparently would trigger fresh congressional oversight as it exceeds that that budgetary cap. So we'll have to see how this unfolds, but definitely a bit of a concern there. Our last item is spin launch. For a long time, people thought of the idea of using some big catapult to serve as a first stage, such that the rocket basically starts with some good speed behind it before it starts burning its own fuel. The general idea here in the past has always been like a long straight catapult that you accelerate down this catapult before leaving the catapult and turning on the rocket. What spin launch is doing instead is they're not going to have this long straight thing. They want to have a spinning thing to build up speed, like a big centrifuge. They think that they can get an initial launch speed of about 3,000 miles an hour, and that this would enable a launch at a cost of only $500,000. We'll have to see how this moves forward. There's issues with the G-loading of spinning something so rapidly that presumably they've already addressed that somehow. So that's our coverage for the final week of February 2018. Check with us in a week or so, and we'll be talking about the first week of March 2018. We'll see you then.